Thank you for finding this video tutorial. This is your day 3 video tutorial. It's Unit 1, pages 5 and 6. Okay, for finding one of our early video tutorials, you get extra credit. So go ahead and write this down, please, the box. Put extra credit, give us a smile, and say video. And then plus 5. Okay. We are identifying Bohr models on this one, D, E, and F. And it says to identify the element. Okay, wants you to write the symbol or the name on the blank. So when we are identifying an element, all we really care about is the number of protons. So here it says 19 protons, means it's atomic number 19 on the periodic table, which is potassium. So you can write K for potassium, or you can write potassium. Okay, either would be okay. For E here, I'm looking at protons, which is right there. Number 3 is lithium, Li. Okay, and then F, be very careful. We tricked you a little bit on this one. 14 neutrons is important for the mass, but number 13 protons tells me what element it is, and that would be number 13 aluminum. So a lot of students are going to write number 14 silicon for this one because they get used to picking just the top number. Okay, the top number doesn't have to be protons, so just make sure we're not tricking you. Number of protons, whether it's top or bottom, is your element number, your atomic number. For drawing the Bohr models, the first thing you need to draw is the nucleus. Okay, and in the nucleus you need to put the number of protons and the number of neutrons. So neon is atomic number 10, which means it has 10 protons. So I'm going to write that, 10 for protons, and then you need to calculate the neutrons. Okay, so mass minus atomic equals neutrons. So a mass of 20.18, it's basically 20. Let's say 20 atomic minus mass minus atomic equals neutrons. I said that backwards. So my mass minus my atomic 10 equals my neutrons, which is also 10. So make sure you give us a labeled nucleus, and then we need to figure out how many energy levels it has. So the period number is your number of energy levels. So in this case there are two energy levels. I'm going to put that in a different color just because I can. So the first energy level and the second energy level. So if it has 20 protons, I need a total, excuse me, it says it right there. If it has a total of 10 protons, I need 10 electrons. The first energy level can only hold 2 electrons. We'll learn why next unit. Okay, but we put our first 2 electrons there, and then I need to put more. So for the next ones, I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So I've got 2 electrons here, 8 electrons on the second ring, which is a total of 10 electrons, so we're good. It doesn't matter for the Bohr model where you put those electrons in the second energy level. They don't have to be 2, 2, 2, and 2. It does matter for Lewis dot structures. It does matter for other reasons that we haven't learned yet, but that makes it easiest for your teacher to grade if you go ahead and do it like that. Phosphorus is number 15. Okay, I'm going to draw a nucleus for phosphorus. I'm going to draw it bigger a little bit so I have room to write my protons, my neutrons. Phosphorus is number 15, which means it has 15 protons. Then neutrons, I'm going to say 30.97. It's basically a mass of 31 minus my atomic number 15 equals 16 neutrons. So 16 is going to be in there. And then phosphorus is in period 1, 2, 3. So I need to put 3 energy levels. 1, 2, 3. Almost circular. Got kind of close there. Okay. So if there are 15 protons, I need a total of 15 electrons. I can only put 2 in the first energy level, 8 in the next energy level, 4, 5, 6, 7, 8. Okay, so that's 15 minus 2 Minus 8 means I still have 5 electrons to put in the next energy level. I'm going to say 1, 2, 3, 4, 5. And there's not really a reason to put them in special spots in Bohr models, okay? Depending on, I suppose, where you're taking chemistry, but we don't have a special way for that. And if you look at it, that looks perfect, okay? Phosphorus is in group 15 or 5A, so it should have 5 valence electrons. That means 5 electrons in its outermost level, which it does. Neon is in group 18, or 8A, so it should have 8 electrons in its outermost energy level, and it does. So I know that those Bohr models, they look perfect. For Lewis dot structures, it's a little bit of a refresher. Lewis dot structures only care about valence. V-A-L-E-N-C-E, valence electrons. Okay? So Bohr models, we talk about all of our electrons. For Lewis dot structures or Lewis dot diagrams, only valence electrons. So if I see 2, 4, 6, 8 dots, I know it has 8 valence electrons. And that means it's in group 8A or 18. So this is going to be any element, that's why it says X, because it can be any of these elements. And the special name for group 18 would be noble gases. Okay. If I'm looking at this one, it says X, because it can be any element in group 2 or 2A. So that's going to be group number 2 or 2A. Okay, so it could be beryllium, magnesium, calcium, strontium, barium, radium, any of those. And the special name for group 2A is alkaline. L-I-N-E, earth metals. Make sure you are memorizing those group names. Okay. All right, let's take a look at page 6. Now, something students get messed up on is they see us put X here at the bottom of this page, and then when I ask you to draw Lewis dot structures, they put X there. No, X is a variable. It means lots of things. So the first thing you do for Lewis dot diagram is draw the symbol. So the symbol for sulfur, S, is just S. And then we need to figure out how many valence electrons to put, right? So for sulfur, sulfur is in group 16 or 6A, and it has 6 valence electrons. So I need to put 6 electrons there. The reason it matters where you put those things, so if it's X, the pattern that we use is important when we learn about sublevels in Unit 2 and S&P sublevels. So you'll understand next unit why this pattern matters. But for my students, I tell them the first 2 electrons share a bedroom. The first 2 people in a house, mom and dad, are going to share a bedroom, unless dad's in trouble and he's on the couch, right? And then your kids are in bedrooms. So 3, 4, and 5 want to go in their own side. Then you would say 6, 7, 8. So that's our pattern for filling in electrons. 1, 2 together, then 3, 4, 5 alone. 6, 7, 8, then half to share sides. Okay? Doesn't matter where I put those first 2 electrons. So just to be difficult, just to prove, I'm going to put my first 2 electrons for sulfur on the side. Okay? That's okay. 1 and 2 can be on the side. That's okay. Or on bottom. But then my next electrons, electron 3, 4, and 5, have to be alone. And since sulfur has 6 valence electrons, 6 is going to share. Okay? You don't have to do this part right here. I'm just showing you that there's an empty space for 7 and 8 right there, because sulfur only has 6 electrons, so I shouldn't have electron 7 or 8. Drawing the Lewis diagram for chlorine would be write the symbol first, Cl, capital C, lowercase l in the middle, and then find the number of electrons. Chlorine has a total of 17 electrons, but we only care about valence electrons for Lewis dot structure, so 7. I need to put 7 electrons there. So I'm going to say 1 and 2 on top this time. It doesn't matter which side it's on as long as they're together. And then electron 3, 4, 5, 6, 7. So the only space left, again, you don't have to write that, but it's right there. There's an empty space because chlorine has an empty valence spot I guess. It has spot for one more as a halogen. All right. Isotopes. This is very important. Isotopes have the same number of protons, but a different number of neutrons. Okay. So in order for carbon to be carbon, it always has to have 6 protons. If it had 7 protons, it's not carbon, it's nitrogen. Okay. But neutrons can change because this is just an average. So almost always carbon has 6 neutrons, but sometimes it has more. Okay, that's what isotopes are. So the isotope number or mass number gets written there. So this says, hi, I'm krypton and I weigh 86 AMUs or 86 pounds or 86 grams, whatever. So in this case, we're going to look over here. Atomic number 54 means that it is element 54, which is Xe, xenon. So I'm going to write that. 54, Xenon. And then I need to write the total mass. I'm not going to write 54 there. I don't put the protons there. I put the mass number, which is protons plus neutrons. So that means 54 plus neutrons, 82, is going to be the mass of this xenon. Not the periodic table number. 54 plus 82 is 136. So I'm going to say xenon 136, like that. But Mrs. Holm, the periodic table says xenon has a mass of 131.2. Yeah, that is the average xenon, is usually 131. This is a very chunky, maybe fluffy or chubby xenon. It has extra neutrons. Okay, it still has 54 protons, it just has extra neutrons, which is most likely going to make it radioactive. And we'll learn more about that in Unit 2. Okay? So the symbol for xenon, capital X, lowercase e, just from my periodic table there. Okay? The average atomic mass, or molar mass, we'll learn about that at a different unit, but the average mass of xenon is 131.294. Okay? This xenon I know has 82 neutrons because I told you on this table. Okay, so the mass number for this one is 136. Total neutrons plus protons. Okay? These two numbers do not have to be the same. Sometimes they are, sometimes they aren't. That's okay. So whatever number you have written here should also be here, just like it was in this example. This one said 86. That one should say 86. This one says 12, so you can check your answer. That one should say 12. That's the total mass. Okay. And then we do eighth man. Atomic number equals protons equals electrons. So my atomic number, 54, equals my protons, 54, equals my electrons, 54. Okay, looking here, they tell me protons is 8, which means I know it's also going to have 8 electrons and be atomic number 8. And number 8 is our friend oxygen. So this is oxygen. O-X-Y-G-E-N, and then leave room for the mass number. The symbol for oxygen is capital O. The average oxygen, usually oxygen weighs 15.999 grams per mole, or AMUs. That does not mean that this isotope has to be 15.999. So I'm going to take my mass number is protons plus neutrons. So in this specific case, not just average, protons plus neutrons, 8 plus 10 is 18. This is a heavy oxygen. It's much heavier than average, which means it's probably radioactive. So my mass number here should be the same as my mass number there. Okay. This one is a little bit harder to learn. The more practice you get with it, and the better you get at it. Okay, number 9 and 10 helps us work with this name dash number. Okay, so it says lead 206 is a byproduct of a nuclear reaction. It's usually a byproduct of uranium fission. Okay, how many neutrons does it have and how many electrons does it have? So this number is, hi, my name is lead and I weigh 206. This number is the mass. That is not protons, that is not neutrons, and that number is not electrons. So I'm not writing 206 for either of these numbers. That's my mass number. So mass minus atomic equals neutrons. So I can say 206, that's how heavy this lead is, minus lead's atomic number, which you can always find, bam, periodic table. Okay, number 82, lead, Pb plumbium is lead in Latin, so it's Pb, doesn't make sense, I know. Number 82, so I know that of this 206 mass, 82 of it are protons, so that leaves blank as neutrons. Okay, mass minus atomic equals neutrons, 124. So lead 206 is a byproduct of a nuclear reaction. It would have 124 neutrons. It would have 82 protons, which wasn't a question that we asked you, but then it would also have 82 electrons. Okay. I actually do want to do number 8 with you as well, just to kind of get some practice. Hi, I'm Carbon and I weigh 14. Hi, Carbon. Nice to meet you. Okay. Carbon is not number 14. Number 14 is silicon. Carbon is number 6. So all carbon, 2b carbon, has 6 protons and 6 electrons. This one has a mass of 14. So that means 14 minus 6 would be 8 neutrons, which wasn't a question that we asked you on this problem, and that's okay. Okay, we're going to take out our garbage on this one. This is very similar to test and quiz type questions. Which of the following properly describes the structure of potassium 40? Okay, hi, I'm potassium and I weigh 40. That number 40 is not protons or neutrons or electrons. It's the total. So that is the total of protons plus neutrons. So down here, if I'm going to take out garbage, A, 40 protons. No. Potassium always has 19 protons, or it's not potassium. 40 protons is zirconium. So it definitely doesn't have 40 of those, or 40 of those, or 40 of those. Not 40 there. Okay. So look, I've already eliminated A and B. I know in order for potassium to be potassium, potassium always has, according to this guy, 19 is my atomic number. So that's 19 protons and 19 electrons. And then I'm going to say my mass, 40, which is mass, minus atomic equals neutrons. Okay? Mass minus atomic equals neutrons. So 40 minus 19 is 21 neutrons. Okay? 19 protons, yes. 21 neutrons, yes. 21 electrons, no. 19 protons, 21 neutrons, 19 electrons. There is our answer. Okay. Great job, y'all. We're going to keep getting practice at this, and you're going to be great.